Hey, welcome back everyone to part 2 of the 3D printed screw compressor project. Apologize for the delay. I had to undertake a little 3D printer rebuild last week, but now as you can see, I've printed out the majority of the parts for the screw compressor. Assembling all this was definitely a challenge with much more post-processing than any of my previous projects. I'll walk you through the assembly and see if we can get this thing up and running and find out whether or not we've created a working screw compressor or a really over-engineered noisemaker. So the first challenge I had was actually printing the 3D rotors themselves. I found that the rotor shapes are very difficult to print on a 3D printer. I'm not sure if it's because of the slicer or because of the fact that I'm using a Cartesian style 3D printer. But I could print them in vase mode and have them mesh together almost perfectly. But as soon as I started adding infill, I wasn't able to get the rotors to mesh properly. So what I ended up having to do was actually shrink the male or the main rotor by 0.5%, which allowed the lobes of the rotor to actually mesh with the female rotor much better and be able to essentially shrink down what they call the blowhole as much as possible. It's still not perfect, but it's a lot better than it was for sure. Once the rotors were meshing, I had to ensure the rotors cleared the liner itself. I started off with a light sanding first, and then I used a large black Sharpie to color the edges of the rotors, and then slid them into the liner to see where they were actually hitting on the liner, and then I continued to sand more down any of the high spots that the Sharpie highlighted. Once I thought I had the rotors and the liner perfectly fitting, I then slid the liner into the housing, and then I discovered the housing itself would distort the liner enough to cause the rotors to hit again. So I had to sand the outside of the liner and the entire inside of the housing. I found the printer didn't print the liner perfectly square from end to end, and it was off by about 0.3 millimeters over its length, so I had to hand file it back to square, and then finally the rotors started working pretty good. Then I epoxied the threaded rods into the rotors, which worked really well. I was concerned the epoxy wouldn't hold well with the PETG, but with the layer lines and the threaded rod, it all held together very well. But when I bolted the ends of the compressor together with the bearings and everything, it all began binding again. So then I hand filed the housing itself square, and I actually lapped the two end caps to ensure that they were perfectly flat. None of this helped at all. Then I noticed the rotors were bound up at the same point every time, so I took the rotors out, chucked them into a drill, and trued them up with a file. Now the rotors and the liner finally fit together really well, but it was still occasionally binding. And then I realized that the 608 bearings allowed about 0.5 millimeter of play with the threaded rod, causing the rotors to be misaligned slightly. So I added some Teflon tape to the end of each of the threaded rods to eliminate any play. Now to finish things off and to free up the rotors even more, I added some polishing compound mixed with some white lithium grease to the insides of the compressor and spun it for about 10 minutes total with my cordless drill, which was an extremely messy process, but left the rotors rotating really easily within the housing and nicely polished all the edges on the rotors themselves. Also right now I'm not running the compressor with the timing gears that I had designed. The reason for this is there was a major design flaw in the retention system for the gears. I used essentially a nylock nut for both gears, which works well for one gear, but when you go to put in the second gear, first of all, you can't actually spin the nut to be able to get the gears to engage this way, as well as there's no good way to perfectly align the teeth based on the tensions in the nuts. So really this gear would have to be redesigned with more of a kind of a compression ring type retention system on at least one of the gears, and it's kind of difficult to fit that into a small gear like this. So I've just ran it without, and honestly with the plastic rotors, and I've been using a little bit of grease, I haven't had any issues with needing the actual timing gears. Now when I first powered this thing up just to see if the motors could spin the compressor rotors, the pulleys on the 540 motors exploded immediately and parts went flying everywhere. Also the main pulley came off and went flying as well. So I learned very quickly that well, first I need to wear safety glasses while operating this, and secondly I needed to make the pulleys much stronger. So I redesigned the pulleys themselves and actually printed them all out of PETG. I also changed the retention design for the main pulley here because I was having some issues. It wasn't very concentric to the actual rod, as well as I had some terrible run out. So that's been addressed now. I will say it's extremely loud, loud enough to hurt your ears even with your wearing earplugs. I think making this housing out of plastic versus the traditional cast iron of the real screw compressor has lessened the ultra quiet natures of the screw compressor. Oh wow, that thing is really loud. I don't know if it's coming through on the recording, but my ears are still ringing. But as you saw, it's actually blowing air. For most of the tests, I was just running one motor, which seems to have more than enough power for this compressor. Now, I wouldn't call this a resounding success. When I closed off the exhaust port with my hand, I didn't really feel any pressure building up. This is most likely because the tolerances just aren't tight enough. Based on what I've read, a screw compressor this size should have a rotor gap of about 50 microns or 2/1000ths of an inch, roughly 4 times smaller than what an FDM printer is capable of. But I did notice a short-lived jump in pressure when spraying white lithium grease right down the intake. So I am going to go ahead and finish the build and actually hook this up to an air tank and a pressure meter so that we can actually see kind of what the flow rate might be and if it's actually building any real pressure. Next video, I plan on jumping back to development on the F1 gearbox. And then once I get the parts in for the rest of the screw compressor testing, I'll most likely publish just a short video showing how it actually performs. Well, that's all for this video. If you like this video, please hit the like button. And if you want to see more content like this, please consider subscribing. Thanks.